go to the agenda and then click on the video camera on the right. Even that looks wrong. Your browser messed up.
That's my old school.
You got some kind of customizations going on?
So I got. Oh yeah, that's fine.
Ready? Okay, let's get started. This is the LSR working group. Here's our note well. It basically says by participating in this, you agree to all these things. Please read it if you haven't already.
So everybody should be in Meet Echo, and here's for on your phone how you log in if you wanna, right?
Yeah. Yeah, you can use the QR on the left there. You should scan that in, and it'll put you in the room. That counts you on the blue sheets. And if you want to go to the mic, you should use that app that comes up, the Meet Echo app, to put yourself in the queue. That way there's fair queuing between the local and remote folks. Actually, Mika used to always do our jabber.
Who did?
Did we?
Yeah.
Do we do that still?
Yeah. I think they use Zula, but I have neglected. Right.
Yeah, the blue sheet coming around is just to remind you for sure to scan that.
So if anybody has any technical difficulties, I'm sure you'll figure it out. I'm pretty sure that joining on your laptop counts too. I know I didn't use my phone as I didn't want to be logged in on the phone and the laptop. Yeah, I'll do the stats. I'm going to go through the stats real quick. Okay, we have one experimental RFC from IETF 16 ISIS flood reduction. We have some fairly important drafts on the queue. Excuse me, how come I got my mic? No. Oh, I want to put my volume down so I don't hear it. I don't hear myself. I'm hearing myself talk. Yeah. So yeah, the OSPF v3 extensions for SRv6 is important because this was the last remaining of the SRv6 documents in the SR, the base SR documents. And apparently the IDR working group was waiting for this because there was a BGPLS that referenced some of the fields in this. So, I mean, it had this as a normative, so it's good that this is now on the RFCQ. IGP flex algorithms, I mean, who would have known when flex algorithms come, we'd have all these different, that it would be so successful. This is just a version, this is just the extensions flex algorithm to allow it to be used without SR. And the others are kind of maintenance drafts, but it was good to get them done, get the application specific link attributes, get the clarifications we needed into both ISIS and OSPF, and the update on OSPF terminology to get the incremental changes for inclusive terminology. If I ever have some spare time, I might redo some of these documents, but I don't know that that's ever going to happen. Next slide. These are two experimental drafts. I think they're both, Tony was the main driver on both these, Tony Lee, and they're good, very good documents, but not a lot of implementation traction. So, but we're doing them as experimental. Next slide. Got fast flooding. I know that was covered at the last IETF that we said we were going to working group last call it, and last week we got it started. I won't say more since it's been covered in the last few IETFs. We'd like to get these 3 Yang models done. I'm an offer on all of them because they're part of the base. The extended LSAs, we really need that for any other extensions, because all the new features, in order to use the TLV base, they have to get the extended LSAs. So for the Yang models, the ISIS SR is pretty much done. The OSPF we had a separate draft for OSPF v2 and OSPF v3 because of the extended LSAs wasn't there, but now we've combined them, so it's good. They're both in that draft. Next slide. I'm not going to say much more about, oh, yeah, all these. I think these drafts are pretty much all ready for working group last call. Be good for the offers once we get through those Yang drafts to push them, you know, to ping the chairs and try and get through them. Next slide. More Yang drafts. These aren't really high priority right now. Next slide. And I have a few other drafts. I think they're lower priority. And the final slide. I'm not going to say anything about any of these. I know we've had requests. I know WeMo asked us to do ISIS topology zone, asked for a working group last call. I don't know how much other interest there is beyond the offers in this one. Anyway, I'm not going to say any more, but we can discuss that on the list. Good. Did you want to say anything about any of the documents that are coming up? Or? Okay.
I need to check on where I was. I think I'm the shepherd on area proxy at least, and I thought we were pushing that through, so I might have dropped the ball there.
Oh, isn't that area proxy? Did I miss that one?
No, we talked about it.
Oh, good. Okay. Yeah.
Okay, so let's go to who's the first?
I think the first one is Les with multi-part TLVs, I believe.
How do
I just have to comment that Les had a college shirt on last night for a different college. I guess he's spreading his support around.
Still learning, you know. But I actually went to Michigan State. So.
Oh, okay.
Did you really? I didn't know that.
Yeah.
Yeah. Okay, I think I'm sure. Yeah, I don't.
So you control.
I control. Oh, you know you. Whoa. Oh no.
All right, you'll control.
Yeah, I should have brought that sheet. You
Okay.
know, I don't have.
I'm Les Ginsberg, talking about multi-part TLVs. Next slide, please. So I realized when putting together this presentation that there's been a lot of discussion about this draft, but it actually hasn't been presented for a year. So a little bit of history. V0 came out in January 2022. V1 came out in July. That was presented at IETF114. One of the things that was added in V1 was discussion of a capability advertisement associated with MP support. There was a lot of debate about that. There's even debate among within the authors themselves. In November 2022, we put out V2. We removed the discussion of the capability advertisement, not because we had reached consensus, but because we hadn't reached consensus. We wanted to move forward with the base MP stuff. So we tried to take out the stuff that was controversial. And V3 was published in May, and the major addition there is a specification of the applicability of MPTLV to the various code points. Next slide, please. So what's the context? The problem we're trying to solve is the base protocol has an inherent limitation. The length of a TLV is maximum is an 8-bit number, so it's 255 is the maximum size of a TLV. With the new features that have been deployed over the last several years, there's a need to advertise more than 255 bytes for some of the commonly used TLVs, particularly neighbors and prefixes. There are existing use of MP today based upon, for various TLVs. There's a list here on the slide. So there's a number of TLVs. MP has already been specified for a number of years. So the natural extension is to use the same technology and apply it to other TLVs, and in particular neighbors and prefixes. Some implementations have actually done this and successfully deployed it and interoperated. But it is understood that if you have a network where some of the nodes support MP for a given TLV and some nodes do not, that the behavior of the network is going to be unpredictable. Next slide, please. So what's in the current draft? We defined the correct way to send MP TLVs. You need to include a key. The definition of the key is specific to each TLV type. And we filled in the example of what the key should be for neighbor and prefixes. It also discusses the receive behavior. If you receive a multi-protocol or a multi-part TLV, you're supposed to use all the information, not choose between one TLV and another. The order in which the information arrives, time-wise, does not matter. The location of the information, whether one TLV is in LSP number 1 and one's in LSP number 100, makes no difference. You just all have to concatenate all this information internally and use it to fully describe the object. We do recommend that implementation support a knob to control enablement and disablement of the use of MPTLV. This is as an aid to the operator, so that if you have a deployment and you don't have, you know that all the nodes in the network don't support MP for a particular TLV, you can control whether it's used or not. And we also recommend that implementations log occurrences, things like I've got MP disabled and I received an MP TLV, or I've got MP disabled and you've done a local configuration that's going to require me to send MP TLVs, but you're telling me I can't do that. So again, these are aids to the operator. Next slide. The other thing that's, again, this was added in the latest version. There was a lot of discussion that the current specifications don't clearly indicate which TLVs MP can apply to. So we decided to, we scrubbed all of the existing IANA registries related to code points, and we are asking IANA to add another column to indicate whether MP applies to that TLV. And we've updated all of the existing code points as to what the initial values should be. And then going forward, any new code points to which MP could possibly apply. This will be part of what they have to specify when they specify their entry in the IANA registries, which means we'll never be back in the situation where you have a TLV and nobody actually clearly specified whether MP applies or not. This, of course, does not mean just because MP applies to a TLV doesn't mean that you're going to have deployments that need it. We can certainly use the examples of neighbor and prefixes. The neighbor and prefix TLVs were invented 20 years ago. We've spent a long time without coming into the situation where we needed to advertise more than 255 bytes. But we are here now because of the addition of new features to the protocol. And so now we need them. Next slide. It's key to understand that the need to advertise more than 255 bytes arises from the features that are being supported in the network. This is not an option. If you're going to deploy, for example, enough flex algorithms with enough attributes that need to be advertised, then you're going to have to advertise more than 255 bytes, or your network is not going to work. So this isn't a choice like, well, maybe I'll send multiple TLVs and maybe I won't. Based upon the features that you're deploying, you're going to have to do it. But again, we do acknowledge that if you have a network where not all of the nodes in the network support MP-TLV for a given TLV, that it's not safe to introduce configurations which are going to require more than 255 bytes to be sent. There's been a lot of discussion about backwards compatibility. Obviously, if you introduce this into an existing network and not all the nodes support MP for a given TLV, the behavior of the network is going to be unpredictable. Wouldn't it be nice if we could somehow migrate? But unfortunately, it's not possible in this situation. Backwards compatibility can be done when you're introducing new information that you're going to advertise. So the legacy nodes, they don't use the new information. They don't need to parse it. They can just ignore it. And that's been the tradition in the protocol. But in this case, we are not introducing any new information. We simply have, well, so much information in the existing TLVs and sub-TLVs that we've already defined that they add up to more than 255 bytes per object. There's no way to introduce this and remain backwards compatible because the nodes that don't understand or don't support MP-TLV for that TLV still need to access the information that you're advertising. So I'd love to be able to put forth a proposal that allows backwards compatibility, but it's logically not possible in this case. Next slide, please. So there have been there's been a lot of discussion over the past year about this. There have been at least a couple of proposals that have come forward. One of them introduces a container TLV, and it says, well, when you get to more than 255 bytes, you take the extra bytes, you put them inside a container TLV. Container TLV is just a wrapper. You indicate which TLV you are extending, if you will, and you put the additional information in there. The authors claim that this can be deployed incrementally, but this is not true. Again, you have legacy nodes. They are not going to understand the new TLV, the container TLV, any more than they support MP TLVs, but they still need to use the information that's inside that container. So this doesn't actually help. Next slide. There's sort of a derivative of this proposal that suggests that Well, if we have a new TLV, could be the container TLV, but instead of using it to advertise only the information past the first 255 bytes, we use it to advertise all of the information. So once you get past 255, you no longer send the original neighbor TLV, for example. You put all of this into this new TLV. But this has exactly the same problems as the original container proposal. Nobody in the network today supports the container. So the effect of doing this is essentially saying, well, when I get to more than 255 bytes, I'm just going to stop advertising the neighbor in the traditional way, or the prefix or whatever. And I'm going to put it in some new TLV that nobody today understands. And then I'm going to have to figure out how I can move forward and wait until all the nodes in the network support this new TLV. This introduces a number of challenges, but the key point I want to make here is it doesn't make life any easier in the network. So it doesn't really help. Next slide. All right, what are the next steps? We'd like to see the MPTLV draft be adopted as a working group document as is. Again, I'd like to emphasize this is not something that's happening in the future. This is something that's happening today. There are existing deployments where we actually are sending more than 255 bytes. So this is not something that we can delay and plan in a few years' time, make sure we're prepared. We actually have to deal with this now. There has been a discussion, as I mentioned before, about advertising some sort of capability. I would prefer to categorize it as a feature support indication, and use this in combination with perhaps some new TLV to figure out how to advertise things. There's a lot of differences of opinion about this. If the working group is interested in discussing this, I think we should definitely have that discussion, but I think it belongs in a separate draft. We need to move forward with the MPTLV, and whether this additional advertisement, whether it's feature supported or capability, whatever we end up calling it, there's a lot of other considerations beyond just the MPTLV. I think it deserves a separate discussion on its own. And with that, have at it.
Okay. So I think I don't like this one. I think that's pretty obvious from what this is as a working group member, not as a chair. I mean, if we were doing greenfield development, we would never come up with a solution like this. We would have something that worked better than this. I kind of liked the big TLV container, but I think that it's not doable. I think that, yeah, I think that this is going to be the solution that ends up winning, but that's as a working group member. I wonder did you not support wide metrics? Is a trick question, by the way.
So should I let you continue?
Yeah, so I'm putting a trick question out there because supporting wide metrics and narrow metrics at the same time with two different advertisements is precisely what you're saying is not doable here.
Okay, so there's a significant difference between those two cases. What we were doing when we introduced the new TLVs to what's commonly called wide metrics, all we started with is there's two different ways to advertise the same information. Mm-hmm. Okay, that's not the problem that we have here. Mm-hmm. The problem here is we've got a bunch of information that nodes today already support and they need to support their features. And we've just got so much content that we can't fit it into a single TLV.
I think that's equivalent to a metric that's wider than was supported.
No.
Yeah. Okay.
I disagree.
Anyway, okay. So, like I said, I'm not gonna stick to my guns on this one. I'll give up. Yeah. Okay. So that's all I needed to say. And I think Wemo is next.
Yeah, I think for the backward compatibility and incremental deployment, Chris proposed an idea which is using or combining capability with container TLVs. Those proposal is backward compatible, and also we can deploy the feature incrementally. I think Chris explained that in detail in the mailing list.
So if you look at the email thread, you'll see that Chris and I had a lively discussion about that, and I responded to all the points. You can agree with him or you can agree with me, but the key element here is that if you introduce a new advertisement, whether it's the container TLV and or a capability, nobody today supports either one because they're not defined. So this is by definition not backwards compatible. The legacy nodes need to use the information that you're going to advertise in whatever TLV you use to advertise the information, and they're not going to have it because they don't support that new code point. There is no backwards compatibility here.
So we just put things easier or simple. So right now, everyone with the legacy, everyone knows runs legacy, right? And then we have new information, and then this new information, new nodes, for example, we say these new nodes support these new features. New nodes include those new information, and then we distribute that one with capability. Those old node, legacy node, just ignore that one, right? And then the new nodes knows that some nodes don't support because we have capability. So, and then we just don't use that new information.
I'm sorry.
As long as those every node support the capability, and then we're happy, and then that's it backward compatible, right?
No. What you're saying is once all the nodes support whatever new form of advertisement, everything will be wonderful. But that you're starting over again. No. And the problem is that what we're calling legacy nodes need the information that we're advertising, not just the first 255 bytes. But all 300 or however much it is.
What you're talking about is impossible mission. Impossible mission. But we are talking about the possible mission, backward compatible. And then maybe we can define what's backward compatible, and then we discuss from there.
So right? I'm happy to take this offline. I think with a whiteboard, we could, in 10 minutes, I can easily demonstrate why this doesn't work.
Tony Lee, Juniper. I wanted to respond to Chris. Chris, you're absolutely right, 100%. If it was a greenfield situation, we would do something much, much cleaner. This is a mess. As a co-author, I'm happy to acknowledge that. We're not happy with it, but it is the best that we can do with what we've got.
Okay, at the risk of AC Lindum, speaking as a working group participant, at the risk of showing my ignorance of ISIS, I'm going to say that if we know we're not going to have a functional capability, OSPF has RFC 7770 has informational capabilities. So if we agreed upon that, it'd be trivial to put an informational capability in that could be used for, say, diagnostic purposes. That's one point.
Sorry. Are you done?
Yeah. With that one, I got one other question, quick question.
Well, okay. Again, I think there's a legitimate discussion that could be had about whether you want to advertise. I prefer to call it feature support, but let's not argue about the name. But that's a separate discussion.
Okay.
It is not going to change the fact that today you need to send more than 255 bytes.
Yeah.
And no matter how you do it.
I agree.
Okay.
Yeah, I was just saying we already do advertise features that we don't ask upon for diagnostic purposes in OSPF. We do, okay? And the last thing is, this is just a question. Can these TLVs with the same key be spread across different LSPs?
Yes.
Okay.
Yeah, I'm happy to take this to the list, but I'd like to explore at least the possibility, if we're just doing an informational bit, to include it in this draft. I mean, I'm not saying like tie this draft up forever with that concept, but if we're really just putting it in there to log messages, why not, why do a whole nother draft for that?
Okay, so
But we can do that on the list.
yeah, but full disclosure here, and Tony's getting up to say his piece. There isn't agreement on this even among the authors of the MPTLV draft.
Okay.
Okay, so there's definitely something that's worth discussing. But I will tell you, I have a lot of input here, and the implications of doing what is potentially proposed goes well beyond MPTLV, and we need to discuss it.
Okay.
Absolutely.
Chris, as you may recall, we started off this draft with a capability
Yep.
bid at one point, and we had many arguments about this, most of them private and offline. And I eventually capitulated because it was very clear we were not going to make forward progress. And there were
Okay.
good points on both sides. It's messy. It's
Yeah.
just messy.
Okay. All right. Thanks, Les.
If you commented on the mic, please make sure your comments are correct in the note taking.
Is it Shada? Oh, yeah. Actually, yeah, we're going to switch the order up here and put Shraddha after the re-presentation. So Shraddha, hang on. We're going to go for, we have this re-presentation of adjacency suppression. I guess just updating with changes since the last presentation. Dion?
Hi, hi, I'm here.
That's a lot of slides for an update. Okay, go
So
ahead.
I see the presentation first.
Oh, do you want me to pass the slides to you? I can do that.
No, it's all right, I think.
I'm passing them to you if you can control now if you'd like.
Okay, thank you. So hi everyone, this is Lian, and this is about the topic of the agency's price for SPF. First, I will introduce this draft briefly. It has been presented at IETF117 meeting and discussed in the mailing list. And this is the second time to present. The brief purpose of the draft is to avoid the OSPF temporary black holes during router's unplanned restart. So the general reason is as the following three steps. I think this has been presented in the last meeting, so I will skip this. Sorry, it's a little slow for the screen.
It changed. It's on changes right now.
Yeah, I can see it. Can you see it?
Yeah, we see changes of the draft.
Okay, I will go up. These are the changes of the draft since the last meeting discussion. First, the draft title changed because the LSR character has been missed in previous name. And the second, we add figures in problem discussion in two routers scenario so that the readers can understand the problem better. And the third one, we add more routers scenario to analyze the problem on remote neighbors. Thanks, Lies, for these valuable comments. And the fourth one, we reorganize the solution using SA indicator and provides three extension options. And this figure shows the detailed process of neighbor state machine, which caused the issue in two router scenario. And it also has been presented at 116 meeting. and it has been updated to the current version. From this figure, we can see that the key point is the step 2 and step 4. The sequence of these two steps has caused the problem. We add a new scenario for more routers. These figures give an example of 3 routers. So we can see on the router C, it's the remote neighbor for the restart router. After the router C has received the new router LC of router B, which has advertised the agency B2A. So the temporary black hole also occurs in this scenario. So the root cause is identical with the 2 routers scenario. So the solution should consider both these 2 cases. The draft proposed solution for these 2 scenarios. The key point is to delay router B from advertising agency or B2A, and so that there is enough time for the restart router to re-originate LSAs with new sequence number. So the main step is shown as the right character. We delayed the advertising for router B to of the agency of B2A. So this idea is much similar with the ISIS in RFC 8706. For OSPF, the signal transmission is different from IS, so the protocol extension is necessary. This draft proposed the 3 options for the extension. Option A and B, the main idea is to carry it in the LLS block of hello packets, which is similar to the IS. And the option C, we call it SALSA. The main idea is coming from the DR function. We carry the signal in a new link local scoped opaque LC. Next page will elaborate detailed. And this is the option C. We introduced a new local link scoped opaque LC to signal the neighbor router not to advertise the agency until sometime later all the LSA has been re-originated. This option are similar to the DR function. So in implementation, this LSA should be sent as soon as possible. Because this is a real problem we might in the practical work, so we have the running code already and have tested in the library. The results shows that this is a simple and effective solution and has no influence on other features or OSPF. After the last presentation, we received a lot of comments through mailing list. Thank you all. And in the discussion, there is a new solution proposed by AC during the discussion. So I have elaborated here. There are unaddressed issues. So the first one, from the discussion, the solution is to add the request list for the router LLC. But I have noticed that the new draft has changed, and it will request all kinds of LLC. But there is still some problems, I think, because requesting all types of LLCs will bring high risk of agency established blocking. And the second one, I have pointed out that this solution will cause bad LLC request event during the neighbor establishment when an older LLC is received at the same time. There is an instance on the sending neighbor's request list. I think this is the key point of this solution. We must first resolve it and then consider the next step. And the third one, as mentioned earlier, for the multi-router scenarios, I think this solution does not work. So black holes still exist. This is the addressed issue, and we haven't received the reply. So we are looking forward for the discussion further. And I think that's all for my presentation. Thank you.
You know, before we get into it, maybe we could do the alternative proposal and then discuss them together. David, did you have something else that you want to talk about? I mean, David's first on the queue. But
Beauty before seniority or something. Okay, Tony P. Juniper. So on the new proposal, number 1 and 2 have been addressed and work. And number 3, I don't see how this proposal can deal with it either, unless you basically hold down the whole network until everybody has the new LSA.
Okay, maybe you can elaborate it detailed later, and we can discuss it, because as I sent in the email, I have discussed it. I think it's not okay. You can refer to the RFC 2328, chapter 13 and step 6.
yeah, we should let David.
Let David go. He was actually in the queue first.
No, I queued myself.
Oh, you gave up your spot. Okay.
Okay, so I want to comment after the other presentation, but in response to what Tony P said, the purpose here is not to determine when everything has been flooded network wide. You're quite correct. You'll never know exactly when that happens. The purpose is to allow the node that has restarted to have time to repopulate its forwarding plan.
David Lamparter. Sorry, I moved myself back on the queue intentionally because this is a much more stupid question. I think the example this presentation started with, the loopback address, is a very poor example to illustrate what this is actually used for, which led to me having problems understanding the actual application because I hadn't looked at it. The loopback address seems to be something that should be handled by the router locally, so I'm not sure why this is the example that is being used here to illustrate the protocol. You know? It's more of a presentation problem.
Thank you. I think the loopback address is just an example. It's a little easier to understand in the draft. All other kinds of LSCs have this problem. So if necessary, we can give another example.
I would appreciate
which will help you to understand it. Yeah.
Who in the room has a jet engine taking off? Please mute that. It's what? A hair dryer. Okay. Okay, let's move on to the next presentation. Thank you, Liam. Oh, it was you. Okay. Shraddha, are you remote? I guess so, maybe. Yeah.
Yes, I'm remote.
Okay, I'll pass you the slides then. There you go.
This is the alternate proposal solving the same problem that was discussed in the last presentation. Yeah, I will repeat the problem statement just in case people have not paid attention. So when a router C restarts, it'll leave its tail LSAs in other nodes, which is the entire database, right? All the routers will have C's old LSA, and that old LSA will have links to both B and E because C was having full adjacencies with B and E before going down. So when C comes up, B and E use old LSAs of C, and as soon as B brings up the adjacency with C, they download the route to point towards C because they use the old LSAs of C and assume that C has brought up the adjacency with B. That they assume that the backlink check in the SPF passes for B when B to C adjacency comes up. So this is the problem which causes black holing because C has not yet brought up its adjacencies and has not downloaded routes in its forwarding table. So if B forwards traffic to C, it might drop the traffic. Yeah, that's exactly what we discussed. So the proposed solution here is the changes are to be done on the neighbors of the restarting router. So the neighbors of the restarting router, they hold the adjacency bring up procedure until all stale LSAs self-originated by the neighbor have been received. And they also request self-originated LS from the neighbor that have sequence number which is different from one in the link state database. So the change is that they don't bring up the adjacencies until they receive the newest LSAs from the restarting neighbor. Let's see in the next slide details of this procedure. So here the C is the restarting router and E is the neighbor. So in database exchange, C will send its LSA with some sequence number X. And then E will, in its database exchange, will also send same LSA, which is originated by C, the sequence number Y. Here Y is the stale LSA, which is left out in E's database from its previous incarnation. So as a response to this DB database exchange message, C sends an LS request with sequence number Y, and on E there is a modified procedure. So E sends an LS request for that LSA with origin C and sequence number X. So when it receives the, so we can see the next step, LSA A with origin C and sequence number X is being received from C, but it doesn't mark the LS request as satisfied. It holds the LS request so that it doesn't bring up the adjacency. So it will mark this LS request satisfied only when it receives a sequence number which is newer from what it has in its database. And as because the it has received an LS request for sequence number Y, it floods the LSA with sequence number 5, and then C reoriginates the self LSA and it will send with Y+1. So these are all standard procedures. There's nothing nothing new here. Standard OSPF procedures. So when it receives Y+1, it will mark the LS request satisfied for sequence number X and bring up the adjacency, because Y+1, Y was its tail LSA, and then it received an LSA which has a sequence number greater than Y. So it then marks the LS request for satisfied and then brings up the adjacency. So in the last presentation, there was a comment that it will cause bad LSA request. That problem has been solved because LS request is being sent for sequence number X and not for Y. Yeah, that's pretty much it. Any questions? And we request review and comments on the draft.
Les?
Les Ginsburg. So two comments. One, a minor comment on this draft. I think it would be good if you had an explicit statement that this does not apply to graceful restart. Just to make clear about that. The bigger comment in terms of the two drafts, this draft has the advantage that it only requires one node to implement this in order to get the benefits. You know, the neighbor of the restarting router doesn't need any changes in the restarting router itself. Whereas the other draft requires both the neighbor and the restarting router to be enhanced. But the previous draft addresses the issue of waiting for the restarting router, not just to get the full LS database, but to populate the forwarding plane before forwarding begins using that node. So I really think it would be best if the two drafts were merged.
Thanks, Les. Leon?
First, I think from this draft, I can see that you have acknowledged that the problem existence and the necessity of fix. And I think this is the outcome of our discussion is valuable. And the second one, I want to confirm that you have said that it has been resolved about by the LS request event, but I do not think so. Because from the figure you can see that after the neighbor router request the LSA, I think from the RFC 2328, the restart router will not send the will send the LSA with the sequence number X, but after that, the router B cannot process successfully. It will generate back the LS sequence. So maybe you can think it again about this problem. And about the second question I just mentioned, for the remote neighbor, I still think this solution does not work well because the sequence of the flooding process cannot be controlled precisely. The LSAs generated first may not received by the neighbor first. I think this is the flooding process of the OSPF. And about the LC type, I will not illustrate it because I found that you have mentioned that you received all kinds of LSA. And in general, I think I agree with the opinion of Lice. maybe we can merge this draft to discuss it together, because I think the two solution has some big difference about it, but in essential, it's resolved the same problem. That's my opinion. Thank you.
Peter?
Must be my new face
Yeah.
cream, man. I just jumped at you. Anyway, Tony P. Juniper again. So just responding to Les's. So that's a valid consideration, okay? How long you want to hold down the adjacency, but I see it basically equivalent to the fact that you don't bring up full until you've wrote all your LSAs into your local database, right? Which seems trivial, but let's assume the stuff is slow or, you know, persistent or something. And then you would also hold down the adjacency until you've wrote through your database. The ASIC is nothing else but an extension of the database, basically projection of the LSA on some computation. And you can just as well put this condition on the LS request and hold it down, just like we're holding down until you get to y+1. So I consider it kind of orthogonal and implementation specific, how long you want to hold the stuff down. That's my view.
Don't, I mean, I'm kidding. Peter?
Peter from Cisco. So I agree with everything that has been presented. I have a question. The solution that has been proposed for LSAs that the restarting router wants to generate after the restart. There can be a case where the restarting router may not want to generate certain LSA after the restart. For example, it doesn't want to generate some redistributed prefix or so. Do we want to address that problem as well? I think it is doable.
Yeah, I have to think through it.
I think it would be good if we can include that. I think we can solve it.
Yeah. Yeah, that's AC Lindum. That's a good one. I'm trying to figure out how that would cause a problem, but because, you know, the problem is if you don't bring up an adjacency, I mean, if you don't advertise a full adjacency when it's, you know, you reuse the router, if you don't reuse that router LSA that's stale, it should prevent any other stale LSAs from being used. Maybe I'm missing something though.
I guess it depends on the order, how you generate your updated LSA and flush the LSAs that you don't want to generate. If that order is not right, then you can lose some traffic or loop if some other router advertises the prefix that you don't want to. So I guess there is a window there.
Keep coming up. Keep walking.
Yeah, in any event, it seems like we need more discussion of these two drafts on the list.
Sorry, so jumping. So there is definitely window on, you know, a large number of LSA externals, yes.
Yeah, I have to. I don't have a big USB, so I got to do it. Do you want me to?
All right, so I'm Peter Pshenak from Cisco. I'm going to present the IGP prefix unreachable draft on behalf of all the co-authors. So just a little bit of history. This has been presented several times. What we do, we describe how we can announce the unreachable prefix in IGPs. We use mostly existing protocol mechanisms, and we want to keep it backward compatible. That is very crucial here. So just a summary, what we do, we rely on the metric being set to a value which is defined by either ISIS or OSPF as unreachable. This allows us to deploy this solution incrementally. There has been concerns that even if you generate a prefix with that metric, it may be generated for some other purpose. So if we want to distinguish this other purpose from what we want to do, we put some specific flags, and actually two of them, U and UP flags, to basically distinguish the reason why we generate this high metric prefix from other reasons. This solution works for all the possible prefix types that are advertised by both OSPF, OSPF-v3, and ISIS. Next slide, please. So a couple of changes that we introduced. Basically, in OSPF v2, we have to advertise these new flags in a different LSA because we have no way of adding them into the original non-extendable LSAs. So what we added in the text, we always said we need to advertise the prefixes unreachable metric, plus you can use these newly defined flags. Unfortunately, in OSPF, these are in the two different LSAs. So what we added as a clarification in the latest version is that even if you advertise this flag in OSPF v2, you still need to advertise the prefix in the old-fashioned with the LS infinity metric. Next one. And in OSPF v3, AC made a comment last time that it would be good if we can use the NU bit. So we added the NU bit as a condition. So when we advertise those flags, we also set the metric to LS infinity, and we also set the NU bit because the LS infinity has not been defined for all the prefix types. So we can use the NU bit, which has been defined for all of them. We kept the LS infinity there just to be, consistent with the OSPF v2. We also specify that for default algorithm 0 prefixes, the LS infinity and the NU bit must be set in the prefix TLV, and the parent one, and the original one, and for the IP algorithm, we set it in the parent TLV, but that has already been mandated by the LSR IP flex algo draft anyway. Right. So what is the next steps? I mean, this has been presented several times. There has been sufficient interest. We have implementation available. There has been field deployments available there. So we just try to ask to bring this document to the working room and finish it and be done with it, because this is a very simple extension and seems like there is an interest in using this solution.
Hi, Dan Boyer from Bell Canada. I'd like to pressure the working group aspect that Pete presented, because so far we have all 3 vendors on this draft. They are already working on it. One of the elephant in the room as a customer here to implement this. So it'd be nice if we don't wait too long before working group adoption. Please. Thanks.
Okay.
Les Ginsberg. Yeah, I'd just like to make the comment. I also strongly support moving this forward. I know there has been discussion in the past because there's an alternate draft with a different solution, but it's been demonstrated that the mechanism in the alternate draft is broken. I really don't think that we need to discuss trying to merge something that's broken into this draft. So I'd like to see this move forward as is.
Thanks, Les. David?
David Lamparter. Speaking as someone who had complaints about this draft earlier, I'm happy to see changes, and I am happy to move this draft along. So I'd like to express my support.
Thank you.
Thanks, David. Okay, I think we could do a adoption call afterward. Yeah, okay, we'll do that on the list later.
All right. Thank you.
Thanks. Next up is the IGP extensions for advertising offset. Is that a remote? Yeah, okay. Let me pass you. I'll pass you the control.
Can you hear me?
Yeah, you should be able to take over the slides now.
All right.
Oh, I have to.
I still just see the old slides.
Yeah, I see that too. I don't know how that happened. It looks like a bug.
Mm.
Let's stop that and then pass you again.
Oops. Dismiss. Do you want me to share my slides or?
Yeah, you should. It should in the app. It should have a where you select your slides. in the Meet Echo.
Okay, so I just turned it off, right? Denied it. Sorry for that.
Oh, okay. Yeah, select.
So I have
your-
to accept, right? Okay, select my slide set. Okay, so hold on seconds. Share.
Okay.
Okay, all right.
Yep.
Okay, good to go, right? My name is Louis Chen. I present on behalf of the group. So about this draft, just a quick recap on the purpose. First of all, is actually help to reduce the IGP advertisement for the per flex algo kind of adjacent set. It is one solution for both ISS and OSPF, and it also taking care of the backward compatibilities with existing kind of flex algo implementation. That means you can compatible with the old implementations of flex algo. And then this one using offset value to predict each and every flex algo adjacent set instead of individual advertisement. That means if you have 1,000 link, you reduction is 1,000 times. And in the 02 draft, we introduced the virtual flex algorithm. I know that people will not like this kind of name, even myself, but because of the ease of understanding, I still use the VFA actually in the current draft, and people can use the PISA for the nickname for this one. All right. So now it's a 03 draft. So next slide is about the applications. So I mean, this can solve some kind of complicated kind of multi-point to multi-point kind of situations, which in during one of the hallway discussions. For example, in the past, if we the R1, R2, R3, right? If R3 want to have a kind of multi-point to multi-point VPN, it's very difficult for R3 to select what kind of traffic from R1 and R2. Okay, in here, these cases, R1 is using as a virtual flex algo 600. R2 is virtual flex algo 601, and they both actually belongs to, I mean, the same kind of, generated by flex algo 129. Okay, which is share the same topologies and actually terminate an R3 over there. So in the C2, this router, we can have this kind of QS implemented with flex algo 129, which is the parent one, which have 10 gig, but split between the traffic between virtual flex algo 600 and 601, which the peak and committed information rate is 6 gig or 4 gig, something like that. So we have this kind of HQS can be enforced in this manner. So it solves some complicated kind of QS, which cannot solve in the past. If you have single label, you cannot solve it, but you have multiple labels, you can do it. So in this case, actually, you can have multiple level. So if it can be 3 levels, more than 600 or 6,001, 6,002, that kind of level, 3 level, 4 level, you can do it, but I don't expect that one. So in this example, also there's 2 more operations possible. One is just single stack of label. That means the top labels is only 1 label, 600, VRFA 600, VRFA 601. Or you can have later on, we'll talk about the compatibility mode for VFA, which can be stacked label. That means the top label is the FA 129 labels. The second is VFA 600 labels. So the next slide is about the analysis of the, advertisements, right? So this is the kind of analysis with only one node with a trendy fact algorithm with 300 links for one node. Just without the fact algorithms, the total number of the advertisement, just the 300 link with algo 0, is around 26 kilobyte. Okay, which is composing of the base, which is a 200 byte to 400 byte, and then additional kind of advertisement of 300 links, which add another 25.8 kilobyte. But then if we add another 20 flex algo with these 300 links, okay, we can compare between the traditional method, which is per link advertisements, which is around 8 byte times 20 times 300, versus this method. The current draft is only 11 byte times 20 because we only advertise offsets. So you see the increment compare is 185% versus 0.85% increase. What does it mean? This means that the impact to the current ISS network is very small because the advertisement is very small here. It doesn't constitute a lot of loading to the control plane. That means all the router, okay, can also take care of this one. Okay, with the lower control plane can take care of this one. And also this one do not add any kind of a major kind of, advertisement kind of message to the existing networks. So this is, I think, a good thing to have. And then in the email discussion, we discussed about different methods, right? Comparison between the two. So there's a one is traditional advertisement method, that means per link advertisement plus fast forwarding, compared with this draft. So there's a comparison actually. So how about first of all, effectiveness? I think the one is should help because you are fast forwarding all these things, use it faster, okay? It should help, but this draft actually, because smaller size, it must help, okay? Because it's physics, right? Small size of advertisement, it must help, right? Faster forwarding should help, but there may be some other problem need to solve. For example, maybe you need to do some kind of damping, route damping, because of fast forwarding may have issues in some cases. If BGP distributed in IGP, right? Then you have to some kind of damping as well. And then the second actually is talking about the network node upgrade, right? Because this method, you need the whole network and nodes to upgrade, okay? But here in this draft, we don't need actually this all the nodes to upgrade. So because we have backward compatibility, which is the next one, okay? There's no need to upgrade the whole boxes because for in this draft, what we're talking about, any flexible implementations or even algo zero implementation will be surfaced. We have backward compatibilities mode, which we'll discuss later on in the slide. And then the control plane requirements, okay? Because we have seen that in the previous slide about the advertisement size, therefore we don't need to upgrade the router with this draft. But if you use the fast forwarding plus the traditional advertisement, that draft, you might need to upgrade the router because the scale, right? The control plane. So this is important for routers which in the transit and aggregation levels. And we're going to talk about N routers, right? We talk about transit one, right? And the last one actually is about ISS OSPF, right? So you need different kind of methods, right? Fast forwarding for different ISS OSPF, right? Equivalence. But here, this solution actually, this draft is one solution for all, okay? So both OSPF, ISS use the same methods. So here we also have kind of discuss, a different kind of allow the configuration in the draft. So there are some which actually do not allow. For example, if your flex algo in the second column, you present the agency offset plus the preset offset. This is not allowed because you should not advertise like this way. Okay, flex algo will be advertised in the traditional way, right? The second one actually is just you have advertised. The fourth column, the VFA, you advertise the agency, but you do not advertise the prefix. Then it's not allowed. So the rest of the case actually I can show in the next slide. So in the next slide is talk about, I think last time we presented about this slide. So algo zero is the one, advertised, okay, as the base, okay. And then flex algo 128 is advertised as normal, okay. And then now we have a 500. But we have a 500, its base algo is based on 128. It only advertised the prefixed offsets. Okay, but it didn't advertise adjacent offsets. Then what the adjacent will be using? It will be based on flex algo 128, which is actually based on algo zeros. So you can see 32, 34, 130, right? All these things, right? This is based on algo zeros set actually. Okay. But 129 last time we've seen, okay, this one we advertise the adjacent offset. In this case, all the adjacent being calculated, but offset plus the algo zero numbers. Okay, so last time we discussed about this one. And for the VF600, I think the same. Last time we discussed, this is the offset, both offsets being advertised is based on 129, and then it will deduct all the rest here. Okay, in the yellow, this column, the one, and the last column is VFA 602. Okay, we only advertise the prefix offset, but we didn't advertise adjacent offset. This is all the valid configurations. That means in this case, the prefixes is it is deducted, it's adding the offset 8,000 to the algo 0, that one, it becomes 4801. Okay, but the adjacent set this time will be fallback using 129 the offsets. That's so sorry, that adjacent set no offsets, right? So it becomes 2032, same as flex over 129. So in this chart, it gives you a lot of flexibility to advertise or not advertise, right? So it gives you a lot of flexibility that whether you use it or not use it, right? In this case, okay, the adjacent set. So the next slide is talk about compatibility mode. So this is mainly talking about the VFA compatibility mode because adjacent set actually you can always fall back, right? Here we have talked about, how to interact with the existing kind of basic flex algo support, right? So we work with this, not only support flex algo. So there's 3 possible barrel compatibility mode. First one's fallback, actually with the FA. Second, fallback with tunnels. The last one actually is the new CSPF. That means you just consider the one of node do not support it, then it's considered as broken. So the network is broken. So we have to spawn a new kind of CSPF for that one. But I think this one is too resource consuming. So we just leave it for discussion only. Later on, we may remove these options. So talk about option 1, okay, to fall back to flex algo only. So here is the R1 sending traffic to R5. And then R3 is the one actually do not support the new VFA, right? This offset, right? So the R3 do not understand VFA. It only understands flex algo 129. It do not understand VFA 600. So when R1 send the packet out, R2, because it knows that R3 do not understand this one, do not understand VFA, it will swap the labels back to FA 129 labels. But 406 become 402. Okay. Subsequently, actually, when the traffic goes along, it will using only 402. That means it's only flex over 129. So subsequently, this one is actually lost some of the information, but it's compatible. Okay. This is mandatory methods. We think this is easy to implement. The next one is a bit better, which is option 2, which is fallback with tunnel. So what it does actually, the R1 send a packet to R5. R2 knowing the R3 do not understand. So what it does is doing a tunnel. Okay, that's a TFA tunnel. It will encapsulate the packet into a FA129 kind of labels, forward to R4. And actually, when R4 receive it, actually the label actually stacked it, okay, with flex algo 129 on the top, and then VFA 600 in the second label. And when R4 receive it, is actually having the original VFA 600 labels and pass forward to R5. Then this one actually tunnel through. So this is a much, I think it's a good method, actually. This is usable, actually, when you saw about the, presented use cases, that one actually using this method is as a kind of good things. So next one actually is, we are thinking about whether the VFA can be localized. There is some merit actually can localize it and changing the L bits, but I think need more thinking because it may need to use the SRLB, right? Okay. So overall, okay, the last one. So we asked for the workgroup adoption on this one. Okay. So as this end of my presentations, I think I welcome questions.
AC Linda, I got a question. So, when you do this, you can't have any holes, right? Once you specify this range, you have to have you have to support all the flex algorithms on that. Say it's an adjacency thread. You have to support all the flex algorithms on that adjacency, and you have to support all these subsidiary hierarchy underneath. What you're calling a virtual flex algorithm, which is a horrible term for it.
So the question is about the host. I do not understand that one.
I mean, you have once you specify this implicit range from the offset to the base. Maybe I'm not understanding it. You mean you have to support it for all the adjacencies. On all the adjacencies, you have to support this all the flex algorithms and all the subsidiary hierarchy below. You can't have any
Yes
holes
and
in it.
no.
So for
Yes and no, actually.
every adjacency, you'd have to support everything, right? You can't have holes, HOLES.
Yes, I understand, but look at the example on the flex algo 129. So if there's adjacent for the interface number 334, there's no participations. Yes, you're correct. There's some holes over there, but those are to be very small number of the label, right? So, and then if you know that this one actually not going to use, you can reassign, okay? But you can do a garbage collections and this one put it back to your usable range if you want, okay?
Les.
Les Ginsberg. I'd just like to mention there are discussions going on in the context of the TEAS working group as to what kinds of IGP extensions, if any, might be needed in this space. And I think until those discussions, until the TEAS working group decides which direction it's going to go, it's very premature to consider this as a working group document.
All right, thanks, Les. Leon?
I want to express is that we have met the same problem in SRv6 channel mobile network. So I think solving this problem can help with FA scale deployment. I think it's very valuable, and we hope we can find a proper solution through the LSR. Thank you.
Ketan Talaulkar, Cisco. So I understand the primary motivation is QoS treatment and using different labels. There are proposals in the TEAS working group to do this in a different way. I mean, there are few proposals there. And I do not see the need to push all these labels and signaling into IGPs at this time. So unless we have something from them, as Les mentioned, I don't think LSR should look at this.
So you're saying what Les said, we should wait and to see what comes out of TEAS?
Yes, there are proposals where you could encode this information in labels.
Yeah.
And the IGP doesn't need to carry any of them.
In any case, things are in flux, right? So, yeah. Okay, I
think just one comment. Actually, because this one also solve a trouble actually advertising adjacency, it's only not solving the slicing itself only, right?
Tarek Saad with Cisco. Hi, Lewis. I see this proposal for the allocating multiple labels and assigning them to different QSs. What's the alternative for loose SIDs, node SIDs and the like? That's number one. And number two, I want to reiterate what others have mentioned about alternative of doing the same thing without extending the IGPs.
Okay, I will be quick. Okay, Jason from Huawei. Firstly, I think VFA may not be a right term for this functionality. It is reserving some link resource for maybe some of the services. This is not what we do with Flex Algo, right? Another thing is, I think that for the stacked label mechanism, I'm not sure it can work with existing the SR mechanism because prefixes is like it will not check the following label on the same node, right? I'm not sure that whether it can work with existing SR mechanisms. Okay.
Yeah, I think a quick reply, it will work with existing fax algorithm because actually very compatible mode. And also we don't talk about resource reservation because this is only about the the labeling, right? It's not about the the actual enforcement, right? And then I'll answer the question actually on the email list. Okay, thank you.
Thank you. Jing Queen? Is that remote?
Yeah. Hey, Louis, why don't you start? You've heard a lot of the concerns with this. Why don't you start discussion on the list? Okay. Thanks.
Yeah, sure. Thanks.
Yes, who's presenting purge originator? The purging from the agenda soon. Okay, well, we can come back to it. We'll move on to Anycast property. So I'll present that one.
Good morning, everyone. This is Zhan Chen from ZTE. On behalf of all the co-authors, next, please. Both SRMPS prefix seed and IPv4 prefix may be configured as anycast, and as such, the same value can be advertised by multiple routers. It is useful for other routers to know that the advertisement is for an anycast identifier. Each prefix is advertised along with an 8-bit field of capabilities. By using the flag field in the OSPF v2, extended prefix TLV, which is defined in RFC 7684. But the definition of anycast flag to identifier the prefix as anycast has not yet been defined. This document updates RFC 7684 by defining a new flag in the OSPF v2, extended prefix TLV flags to advertise the anycast property. Next, please. For OSPF v2, it updates the anycast property advertisement. RFC 7684 defines one octet field contains flags applicable to the prefix, and a new bit in OSPF v2, extended prefix TLV flags, is defined to advertise the anycast property. For BGP LS, based on 9085, it just extends the interpretation of the flag field of the prefix attribute flags TLV. Next, please. Compared to the previous version, we had made a couple of changes. First, we removed the existing for OSPF v3, and this part has been added to the draft IETF LSR OSPF v3 SRv6 extensions. The second is it followed the extension of RFC 7684 and defined a new flag in the OSPF v2 extended prefix TLV flags to advertise the anycast properties. Next, please. This draft has been done the practicing many times, and we think, and we would like to request the working group adopts this. Thanks.
Sorry, AC Lindum. I had one comment. You know, for ISIS, this already exists, so it's sort of a maintenance draft. I mean, I think we should adopt it. There's one thing. The draft says it is useful for routers to know that a prefix is anycast. Can you put why it is there? Can you put the use cases into the draft? I mean, that would be useful because for ISIS, it just went in as part of, was it segment routing? Segment routing. So this draft is specifically on anycast. It would be good to have capture some of those reasons why. Thanks.
Yes, I think it's the same reasons. Some draft in Spring working group and RTG working group, it can be used on redundancy and protections, which may be used the anycast flag.
Yeah, he's saying just put that in the draft.
Yeah.
Just,
Okay, thank you.
Shraddha.
I had similar comment what AC made. So the use cases on how OSPF routers are going to use this information will be very useful, because all those protection use cases today have been working without this anycast flag, right? We use NBit or whatever. So I think it's really useful to have those use cases in there, and also mention, because this is coming in new, there may be routers that get upgraded. They might advertise, might not advertise. How does the receiver router for that whatever use case this is being proposed for, how does it interpret uh, when there are routers that don't advertise this information? That is, I think, very much necessary for this draft.
Okay. Wemo.
Hi everyone. Today I'm going to talk about.
Here, scoot that like.
Okay. Hello everyone.
Doesn't that work?
Today I'm going to talk about the IGP.
No,
Maybe it's off. Hello? No.
it is, but it's not.
Okay, thank you.
Sorry.
It's okay?
Yeah, that's better.
Okay, thank you everyone. Hello everyone. I'm going to talk about IGP for temporal links. Next page. First, I'm going to talk about temporal link cost functions through example networks. I'll focus on periodical cost functions and then extensions to IGP. Next page. In general, the cost of a link is a constant, such as default cost, which is computed by reference bandwidth of the link or configured on the link. However, for some kind of special links, for those links, the cost of those links depends on the time, which is a function of times. So these kind of links we call the temporal links. So here we just give an example of link cost functions. So here from time T0 to T1, the cost of link is C0. And then from time T1 to T2, the cost of link is C2 and so on. So let's look at details about link cost functions. Next page. So first we will describe those cost functions through example networks. Here is an example network. The satellite nodes SA, SB, SC, S1, S2, S3. Those are satellite nodes. And then we also have ground nodes, which are nodes on the ground, node A and node B. There are links between satellite and the ground node. Those links are temporal links. We know that a satellite runs around the Earth in its orbit once every period. For example, a Starlink satellite goes around the Earth every 5,700 seconds. So during this one cycle, that satellite can see a ground station for a time interval, for example, 400 seconds. So that means that in one cycle, and then the satellite can have a connection to the ground node for 400 seconds, and then the link is up. And then when that connection is on, and then we have a cost, we have a link cost. And then after that interval, that means in the rest of the period, and then the link is on, and then satellite cannot see the ground node. So we can see that the link between a satellite and the ground node is a temporal link. So let's look the functions of this kind of cost functions of this kind of link. Next page.
Are these actual numbers or are these example numbers?
This is I got from the internet. For example, that's is close to real number. So the period is 5,700 seconds. Is 95 minutes. I get it from internet. And then the time interval exactly is 398. I just give roughly 400. It's close to real. So one typical cost function is a periodic function. So here, that means that for each of period, 5,700 seconds, and then there's an interval, time interval with 400 seconds, and then the link will be up. And then the rest of the time of that period, link is down, and then we have infinite cost. So here, the figure on the top illustrates that from a given time, t0, and then from that time, in every period, and then link will be up for 400 seconds, and then link will be down with infinite cost for the rest of that period. From t0, and then link up for 100 seconds, and then down for 5,300 seconds, and then for the next period, and then link is up for 400 seconds, and then link is down, and then for 5,300 seconds, and so on. So this is the periodic cost functions. So this kind of cost function can be encoded by a TLV, we call the link cost function TLV, and then more specifically is a recurrent time interval TLV. So this TLV contains start time, the interval length, and then the period. So this TLV with start time t0, and then time in length 400, and then period 5,700, and then this TLV encodes the cost function on the figure on the top exactly. We know that the connection or link between a satellite and the ground node is a microwave or laser. So this kind of connection or cost or bandwidth of that link is dependent on the weather. In a sunny day, and then we're happy we have big bandwidth. But in the cloudy, rainy day, the link bandwidth will be reduced greatly. That means the cost of link will be jumped greatly. So so this kind of effect or component of the function can also be encoded, represented. Next page. So this just gives us some component of link cost functions for some special case. For example, if we know from broadcast, weather broadcast, or for some given period, so we are sunny or rainy days, then the cost of a satellite link will be bigger. And then, for example, CA is a bigger number. So here we give an example. So for 2 period, and then from time t0 prime, so from this 2 period from this start time, and then the link cost will be bigger. For example, CA is 2 times of general cost C0, and then we can represent this or encode this kind of component, function component by a TLV called limited recurrent time interval TLV. So this TLV includes start time, and then the interval length, and then the period, the number of period, and then the cost. So this using this TLV, we can represent or encode the component of the this function. So next page. So this also just represent a special component of the cost functions, and then we don't need to go to these details. It's just this. So this one just give for special time interval, and then we know we have some condition, weather condition is not good, and then the link cost will be such, and then within this time interval, when link is up, and then the cost of the link will be a given cost. Next page. So we can see that a cost function is a combination of those periodical and then given time interval and given some period. So the cost function can be encoded by combination of sub-TLVs, which we already presented. After the link cost function is configured on a link, and then the node will distribute these link cost functions. So in OSPF2, so for different IGPs, OSPF version 2, version 3, and ISS, and then we can distribute these sub-TLVs. For example, in OSPF version 2, we can include those sub-TLVs in OSPF version 2 extended link TLVs, and so on. In addition to that, every node will maintain the status of a temporal link. So those status will include the function sub-TLVs, the link down and up. And in addition to that, we'll also maintain a timer, which is called earliest link cost change time. So at this time, or before this time, a node can compute the shortest path using the link cost at that time, and then build next routing or forwarding table based on that path. So when time reaches to that earliest link change time, and then we can just switch the routing table or forwarding tables. That means that when we use the routing table for forwarding table already computed, and then just do the switch over, and then we find a new earliest link change time, and so on. So that's all about this. Next page.
Cursor went off. Hang on.
Yeah, we would like request comments.
Okay, David.
David Lamparter, can you clarify how this relates to the work being done in TVR, and in particular to the TVR draft for applying TVR to ISIS and OSPF?
You mean in the NASA working group?
Yes.
About a variable time, whatever. I don't know. That depends. So if we can put, looks like this is some kind of related. This is because this is related to the time for the routing table, whatever the states.
AC Lindum speaking as a working group participant in both working groups. I would say that the scheduling in the Yang models that are being presented are independent of the IG usage of those is a separate draft, a separate problem, separate problem. That would be my statement right now. Would you agree?
I think it's considered here.
Hi, Tony Lee, Juniper. I'm TVR Working Group Co-Chair, and this is with my hat on. So first of all, TVR Working Group is addressing exactly this problem, and it, perhaps that this is not appropriate for here, but okay. With my hat off, this doesn't seem like a great way of solving this problem. This seems overly specific. There are lots and lots of link attributes that are going to change over time. Okay, delay is going to change. We can have SRLG that changes. We can have affinity groups that change, yada, 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 yada. Wouldn't it be nice to have a more general mechanism so we don't have to re-engineer our IGPs from the ground up?
Yeah, I agree. There are lots of changes, and then this one just so focus on one or few changes. I agree with you.
So
Yeah,
what we're trying to do in TVR is to propose a Yang model change so that we can circulate information so that when these changes happen, nodes that want to know about it will know about it beforehand, and they can know when it's going to happen exactly, and they can act on it. If they like, they can actually pre-compute things.
Yes,
Okay?
yes, that's right.
So,
And
so
so
maybe go to TVR and hang out with those folks.
So you don't need to change the IGP.
My comment was going to be sort of similar in the sense I was going to say this is another KISS opportunity, I think, right? Like this is a really specific, complex solution. I think you need to be more general. The other thing I was going to say is I don't know where you're from, but in Michigan we have this saying that if you don't like the weather, stick around a few minutes. So that might not have been the best thing to example.
I guess I'm up AC Lindum, again, speaking as a working group member. The first thing I'm going to say is specific to the draft. OSPF does not have a way to use a metric to say a link is down, an infinite. So you'd need explicit signaling. I mean, you need a flag or something to say it's down. ISIS does, OSPF doesn't.
I agree.
Yeah. The other thing, and this relates to what they're saying. I mean, this is more. There's different ways you can do this, and this way of doing it, having all the routers doing these actions independently, it's more fragile. So there'd have to be a real. It's more complex and it's more fragile than sticking with something simpler. That's the other one. So you'd have to tell how this is going to be better by doing that. And the third thing is this synchronization of, the routers definitely have to have all their clocks synchronized. And that let's say that everything else comes and we say, oh, let's do temporal links. That would definitely be a security vulnerability, that the clocks, and that would be a new attack vector for this draft. That's it.
Yeah, generally I agree with you. Yeah, that's right. Yeah. Thank you.
Okay, thanks. I guess one more, Louis.
Yeah, actually, Louis Chen from Juniper. I agree what AC is talking. Actually, you need clock synchronizations with all the nodes. Otherwise, we will run in the routing loops, which is easy to have, right? The second thing, actually, you might need to source routing. Otherwise, you have this kind of routing loops, right? So, but then once you use source routing, that kind of methods, then you're running into kind of situation of race conditions. That means the packet will drop in the middle once you do the source routing. So that's my comment.
Yeah, there are lots of work needs to be done. For example, synchronize the clock on every node. That's a mass minimum, and then there are also lots of work there. So because this is just the start work, and then maybe, yeah, we need lots of work.
Also, the CF will do at the same time. This is a problem as well.
Yeah, I mean, we've never been able to agree on a synchronized clock thing. We could have done all kinds of crazy stuff with, switching fibs at the same time, and that's been something we just don't think we can tackle. So it might have kind of shot the proposal in with that one. But that's just an opinion. I'm just saying as a working group member. Okay. I think the presentation we skipped, they're here now. So I'm going to switch back to them. Thanks, Wimo. Shenwang. I'm passing the control to you if you select your slides.
Okay. Can you help me to control it? I can't control this.
Try it. It should bring up a list of slides right now, and then you should be able to select yours.
Oh.
There you go.
Yeah, okay. I'm Chang Wanlin. I'm going to talk about the project originator identified for OSPF. First, let's take a look about why we need to trace the purge. The scenarios on the right picture is a typical problem encountered by IGP purge. In the case of a fake loud one due to incorrect configuration or soft bug, a purge LLC is triggered, and this LLC will purge is flooded throughout the network. When loud one received a purge LLC, it reoriginate LLC. If this regenerate LLC is passed to the fake loud one, it generates a purge LLC again, leading to a network acceleration. So the network administrator is having difficulty quickly locating the source of network issues because they cannot identify the true originator of the purge LLC. Next, we take a look about the current state of purging tracing support in IGP. In FC 16.2.13.2, purge originate identify TLV for ISIS. The ISIS POI TLV is added to the purge RSP in order to record the system ID of IS that generate it. At present, OSPF purge RSA does not contain any information that identify the routers that generate the purge RSA.
That might be it. This seems strangely silent. Did we lose you? You might be rejoining. Well, next slide. Just know that we can't hear you. Yeah.
Oh,
There you're back now.
okay.
Yep.
The current state of OSPF purge RSA does not contain any information about contain the routers that generate the purge. So this makes it difficult to locate the source router. Therefore, for OSPF, a similar mechanism for identify the originator purge is needed. So therefore, we are proposing a solution for OSPF because ISIS LSPs can be extended by inserting any TLVs. However, OSPF-based LSAs cannot be extended by inserting new TLVs due to their fixed format. Therefore, in order to carry the POI information in OSPF, new LSAs need to be defined and extended. While the faked route 1 send purge LSA, it also generates a POI LSA to indicate itself as the source of purge for the LSA. Based on information of POI LSA, the network administrator can determine the purge LSA was generated by the fake router and first received by route 4. This enables quick to identification for the faulty location. When deploying this solution, it's important to consider compatibility with the existing.
Uh-oh. You're gone again. It reminds me in the old days when you didn't get the refresh right on your NAT entry.
For example, a fake the route 1 sent to purge LSA to route 4. When route 4 receives the purge LSA, it generated the corresponding POI LSA on behavior of fake route 1 and advertise this purge LSA was generated by the fake route 1, as it is known that the fake route 1 does not support POI capability. By extending the capability of neighbor hello packet, we can obtain the information about the neighbor's POI capability. Given that the fake router does not support the POI LSA capability, route 4 become aware of this during neighbor exchange. Therefore, route 4 is capable of sending POI message to notify the source of purged LSA. The POI LSA are only flooded to the neighbor that support the POI capability. Final, let's summarize the solution. First, we announcing support for POI capability where an extension in the hello packet. Second, we define the specific contact for POI information in the new POI LSA. Third, the POI LSA are only flooded to the neighbor that support the POI capability. So this solution can be incompatible deployed and allow for compatibility with the existing OSPF network. Let's take a look at specific theory and LSA extension device. Extension number one, the POI capability in hello packet. We divided purge signal in extend option in LS blocks. It indicated the support for the POI capability. Extension number one, just new POI LSA for OSPF are defined. And also new POI LSA for OSPF version 3 defined. Final, we define the POI TOE used by OSPF and OSPF version 3. The POI information that advertise include the link state of the purge LSA, the originator of the POI LSA, and whether the POI LSA is generated for a specific neighbor. Yeah, that's all. Any questions, comments? Thank you.
AC Linder speaking as working group member. Actually, for OSP, because this went into ISIs because it was convenient to do so. At least with this proposal, it's not convenient to do it with OSPF, and what you're proposing, the medicine is much worse than the problem you're solving. Also, it's kind of funny, if I were going to, you had one example where somebody spoofs the purge of an LSA. Now, if I were going to spoof the purge, I wouldn't send another LSA announcing that I did it. That wouldn't be a good attack on a network. The other thing is, in the cases where you do actually purge someone else's LSA, it's when it times out. So given the propagation delays, it's going to happen. Somebody goes away, they have a bunch of stale LSAs, they time out, and everybody's going to more or less purge them based on their propagation delay. And so most of them are going to purge it without getting a purge from somebody else. Now you're amplifying this by 2, the number of LSAs when this stale LSA goes out. So I don't know why we'd want to do this.
It's Peter from Cisco. So basically, I agree with AC here. You are trying to solve the problem, which is valid. I agree with it. But the way you are proposing to do it, it's not going to work. It's going to bring more problems than the good.
We can generate POI LSA only for a specific type of LSA. Also, we can limit the potential impact of performance and ensure the POI LSA is generated only when needed without the normal function of purge LSA. So we can limit it to the intra-area LSA, just for root LSA, network LSA, or inter-prefix LSA. We have encountered situation where nearby 100 devices starting purging, and it was difficult to identify the source of problem. So for operations, this causes various issues. It's important to quickly identify the source of purging.
Okay. I think the discussion would need to list. Yep. All right. That's it. So thanks, everyone. See you at the next one.
If you commented again, please make sure your notes in the note taking are correct. I missed some and
Yeah, thank you.
Hey, John. Good to see you. There is no button.
It's like, yeah, I went to Ottawa twice. I went to Ottawa twice. Yeah, I wasn't able to get home. I was devastated.
In the office?
February.
I'm not going to the office these days. Still working on the same things or different things?
Working on the segment routing services. Have some cloud stuff.
Okay, that's interesting.
Yeah, that's quite interesting. I have a lot of discussions, a lot of back and forth.
You're staying in the US mostly, or?
My children are in college. The three old ones
So you
are in
have
college. Yeah, since 2020.
in the US?
Well, the first one in college in 2020. The other
You have to keep working. All good. We should talk more about what you do.
Although I came to Ottawa twice, actually.
I didn't know. You don't announce that.
When I walk around to
Then
look
we
for
can,
people.
we can roll down the red carpet.
I can't find anyone. I saw Yuri, Eric.
Yeah, no, they're not showing.
Candy, I saw him a couple of times. Mike, John Parker, I saw all these people. And I looked around, I couldn't find them. And when we go there, we are quite busy, super busy. Running around like crazy.
انت جيت لشيء معين يعني ولا؟
لا انا في بيتي بس انا I drove and I'll go back today. I'm not staying here. انا عشان كده انا جاي عشان for this one I came today all day I'll stay. Come on Tuesday maybe Wednesday. I think Wednesday there is the spring. I won't come here. Many people that are here.
Yeah. Yesterday was you saw me yesterday. I just walked out. A little bit of mozzarella. I hadn't eaten, like, because I was. They always say, stop drinking all the coffee. I don't know. Ace left his laptop here. Yeah, I could be went to the bathroom. Yeah, I have a bunch of things to do, but I'm not gonna work out. I'm not walking up and down hills. I'm walking. Now I have a good excuse. You have this AI thing, is that today? Yeah, that's great. Maybe. Yeah. There's other like non-IETF work I have to work on too.
worried about this.